Synthetic division works only if your divisor is a linear polynomial, which means your divisor should look like either x minus some number or x plus some number. In that case, synthetic division will work. In an earlier video, we talked about dividing polynomials using long division, and this is what we did. If you have a polynomial like this, x cubed minus 6x squared plus 11x minus 1 divided by x minus 2, we wrote x minus 2, the divisor on the left. Then we wrote the dividend up here, and then we wanted to divide term by term. How do you get rid of this x cube? You got to have x square there, because x square times x would give you x cube, and then x square times negative 2 is negative 2x square. You subtract, and then finally you get some remainder if you get. Otherwise, you will get remainder of 0. Now, and then you can write down your answer as quotient plus that remainder over divisor, just like you would carry out long division of numbers. For synthetic division, it's much less, and it's not going to be, you don't use any of the letters, so no variables involved and no subtractions. It's all additions. So let's do this same problem using synthetic division. So let me copy the problem. X cubed minus 6x squared plus 11x minus 1 divided by x minus 2. In synthetic division, however, we have to keep this in mind. What we are going to do is we are going to not write the entire dividend, but only pull the coefficients. What number do you see in front of x cubed? If you don't see anything, that's a 1. Then the next coefficient is negative 6, and be sure to copy the negative part as well. Then the next coefficient is positive 11, and negative 1 is also a coefficient. You want to include the constant term. This is like coefficient of x to the power 0 if you want. So let me repeat this. We just pull the numbers. We ignore the variables. And here is the thing. If you are dividing by x minus 2, then you want to write positive 2 here. All right. So this is our first step. Write the coefficients, then if it's x minus 2, you're going to write 2. If it was x plus 2, I would have written minus 2 here. And here is what we are going to do. Under the first letter or under the first coefficient, you want to write 0. So you begin with 0, and what you are going to do is you are going to build a line of numbers up here and down here. So how you are going to build is you add these two numbers and write down the sum. 1 plus 0 is just a 1. Now what you do next is multiply this 2 with 1. 2 times 1 is 2, and you write the product up here in this line and repeat the process. So keep going. Negative 6 plus 2 is negative 4. Remember, this is addition. And 2 times negative 4 is negative 8. 11 minus 8 is 3. 2 times 3 is 6. Negative 1 plus 6 is 5. And the last digit you see, the last number you see is the remainder. And what you have here is the coefficients of your quotient. So if you are dividing a third degree polynomial, cubic polynomial with a linear polynomial, the quotient is going to be a second degree or a quadratic polynomial, and the coefficients are going to be that. So let me write down x cubed minus 6x squared plus 11x minus 1 divided by x minus 2 happens to be a quadratic polynomial with these coefficients, meaning I'll have x squared quadratic. So the highest power is 2. Then the next coefficient is negative 4. So it would be negative 4x. Then the next coefficient is 3. And 5 is the remainder. So I can write 5 divided by x minus 2. Now, this is exactly what we had when we did the long division of polynomials. You got x squared minus 4x plus 3 plus 5 over x minus 2. Notice the coefficients 1, negative 4, and 3. That's what we had 1, negative 4, and 3. And the remainder, the last digit or the last number would be the remainder, and that's what we have. So that synthetic division again works only when you have to divide by something that looks like either x minus a number or x plus a number, and you write the opposite one here, build this line, build that line, and then you're done.